This is part 8 of section 6.4. If a river flowing southward has a current of 4 miles per hour, and a motorboat in still water maintains a speed of 15 miles per hour, the motorboat starts at the west shore on a bearing of north 40 degrees east. What is the actual speed and direction of the boat? So we are asked to find both the magnitude of the resultant and the bearing of the resultant. Okay, so let's get a picture drawn. So we have some sort of coordinate system, and this is north, south, east, and west. Okay, the river is flowing southward, due south, with a current of 4 miles per hour. So it's flowing this way, and it is at 4 miles per hour. Now, a motorboat starts on the west shore and goes on a bearing of north 40 degrees east. So north 40 degrees in the easterly direction. Okay? So, all right, the motorboat itself can go at 15 miles per hour. Okay, so now we need to find the resultant of these two forces. Now, we have to assume that he eventually does make it to the eastern shore. So the resultant's probably going to be somewhere in here. Okay? So, but I need to find a vector representing the southward motion of the river, and I need to find a vector that's talking about the motorboat, and then we'll add these together to get the resultant. Okay, so first of all, let's deal with the river. Okay, I'm going due south, which means I have no I value. It's going south, so my J is going to be negative. So the river's vector is negative 4J. That one's pretty easy. Okay, so let's look at this one. Now, we know that we have a formula if we have this value, this angle value right there. Well, this angle and this angle are complementary. So to find the theta I need, it's going to be 90 minus 40. So my answer here, that angle that I'm looking for, is 50 degrees. So for the boat, our vector is going to be the magnitude, which is 15, times cosine of our angle, I, plus sine of our angle, which is, 50 degrees, and that's going to be J. So I'm just going to distribute this 15. These aren't exact, so we're going to have to use our calculators here. So I'm just going to write things down the way they are first, and we'll do all the calculator work at the very end. So this is 15 cosine of 50 degrees I plus 15 sine of 50 degrees J. Now, our resultant, which is the answer that we're looking for, their answer vector, is going to be these two vectors added together. Since this one does not have an I value, it's going to be 15 cosine of 50 degrees I plus combine like terms here. And since we don't have a value for that yet, this is going to be 15 sine of 50 degrees minus 4j. Okay, so what I generally do here, since we need to keep our values as exact as possible, what I'm going to do is I'm going to calculate this value, and in my calculator, I'm going to store it as variable x, and I'm going to calculate this value, and I'm going to put it in my memory as y. So I'm in degrees, and I have 15 cosine of 50 degrees, which is that big ugly decimal. I'm going to store it in my x variable. All right. Now I'm going to do 15 sine of 50 degrees, and then subtract 4, and I'm going to store it as y. So I have those two values exact stored in my calculator. All right, so we're asked to find the actual speed, so that means we need to know the magnitude of r. Now the magnitude of r is going to be the square root of this whole value, which I'm calling x right now, plus all of this squared, so y squared. And this will be equal to, if I take the square root of x squared plus y squared, I get approximately 12.2, and this is in miles per hour. And if you think about it, this makes sense. If the boat can go 15, but the wind's blowing you south a little bit, it's going to slow you down some. Okay? Now, I need to find the bearing, okay, which means I'm going to calculate this theta, and then I'll have to find the bearing because theta is going to be the angle between the x-axis, and I'm going to need it for the y. All right? So, tangent of theta is going to equal all of this over all of this. So rather than writing the whole thing down, I've defined new variables. So that means the theta is going to equal inverse tangent of y over x. So let's see what that gives us. Inverse tangent of y over x. And we get that theta value is approximately 37.8 degrees. So that has given me my theta value to my resultant, but it gives it from the x-axis, and I need the definition, the angle from the y-axis. So again, these need to be complementary. So I do 90 degrees minus 37.8 degrees, which gives me 52.2 degrees. So the bearing, this was the speed, the bearing will be north 52.2 degrees east.